So this lesson today is going to be on ellipses, and we are going to start by talking about some of the parts of ellipses. Ellipses can be wider, like horizontally, or they can be wider vertically. But whichever way that they are wider, you will have what's called the major axis that runs through it from end to end. And the shorter direction will have what's called the minor axis from side to side. So you will have a center, which will be right there in the middle of those. Now, with our equation that we're going to be looking at, we will have values that we will know as A and B. And in many textbooks, these will change. They will put A with the major axis every time and B with the minor axis. I don't do that. Okay, I go against the textbooks just because it makes sense for me to keep it the same letter all the time. So what A is for me is the distance from the center to the vertex on the major axis, or on the x-axis, whichever way that is. In this case, it happens to be the major axis. But it's the same distance here or on this side, which is not labeled, but it's that horizontal distance from the center to the edge. B, I use as the vertical distance from the center to the edge. So in this case, it happens to be on the minor axis, but in my world, it could also be the major axis. So B is the distance from the center to the edge. Now, you will also notice two red dots here on my screen, and those are our focus points. And again, if we could nail down a piece of string at those 2 points and let it have some slack and then pull it tight with a pencil, we could draw this ellipse. So those focus points are usually they are inside of the ellipse, and they are on the major axis every time. Now, there's a distance that we use to get to those that we have not yet labeled. So let me label that. The distance to your focus point is C. So from the center to the focus point, either side. So this distance is C, and also this distance is C. Okay, just to those focus points. Don't get it confused with the A, which is going all the way to the end. The C is the distance between the center and the focus point. Okay, so the next thing I want to talk about is the standard form of an ellipse. And in this case, you'll notice the top of it should remind you kind of the equation of a circle. You will have an x minus a number squared and a y minus a number squared, and those h and k will become your center, just like they would in the equation of a circle. On the bottom, I have a squared and b squared, and sometimes in problems it'll be a number like 9, and then obviously a would be 3, or sometimes they would have like the 3 squared written in. But because I do things the way that I do them, I always will have the a value under the x and the b value under the y. For me, A is the distance from the center, left and right. So it's how far I go left and how far I go right. B is the distance from the center, up and down. And then C is the distance from the center to the foci. And again, these should always be located on the major axis. So sometimes that's left and right, and sometimes it's up and down. Okay, so how do we find that focal distance? So the distance to those foci, that's C. There's an equation, and again, it's going to be written differently in a textbook, but I use C squared equals big minus small. The big and the small numbers are the a squared and b squared, which would be the bottoms of the fractions above. So if I come back up here, I'm talking about this number and this number. So whichever one is bigger, I'm going to do the big minus the small, and then I'm going to say C is whatever the root of that number is, because this is c squared. And that should give me that distance to count and graph. Okay, so we have an example here we want to sketch. This ellipse is in standard form already. Now you will notice the top here is just x squared plus y squared. And that means that it was x minus 0 squared and y minus 0 squared. So what that tells me is that my center is at 0, 0. So that's what happens when you have just the x squared and y squared in the equation, which is on occasion. So this thing is centered at 0, 0. The next thing I want to find are my a's and b's. So a, I'm going to look under x every time, and I'm going to take the square root of that number. So what is the square root of 9? 3. So a would be 3, and b would be, under the y value, you take the square root of that number, so b would be 4 because the square root of 16 is 4. So the a and b are easily located, and I can draw this thing just knowing those, but I also want to be able to have my focus points. So I'm going to say c squared equals big minus small. So I come back up here, the big number is 16, the small number is 9. So c squared is actually 7. And then c would be the square root of 7, which is about 2.6. Okay, so now I'm going to come over here to my graph, and I'm going to mark my center just so I can remember to count. And since a is 3, I'm going to go left and right 3. So this should be one of my vertices, and this should be the other. And so if you are asked the question, what are your vertices would be at 3, 0, negative 3, 0. Those would be your minor vertices. Because your major axis will be the y-axis in this case, because b is bigger than a, and I'm going to have to count up to 4 and down to negative 4. So my vertices on my major axis would be 0, negative 4, and 0, 4. And they may not ask you these, but if they do, you can list those out. And if you need to distinguish between the major ones and the minor ones, you can do that. Then you can do your best to sketch an ellipse. Mine is definitely not going to be perfect, but hopefully on your paper you can get the gist of it. And this thing likes to erase what I do. I'm not sure why. And then finally, I'm going to choose a different color here. I'm going to go back and put my focus points in. I'm going to use roughly 2.6. You're really just estimating. And they need to be on your minor axis. So from the center, I'm going to count what close to 2.6, excuse me, which would be right in here, and down 2.6. On your major axis every time. Again, your major axis is whichever axis is longer in your graph. Okay, let's move to another example. Example 2 is slightly different because it has a center that is not at 0, 0. The center for this graph, I'm going to look up here. It's always different than the sign that is in the equation. So if this is x minus 1, the x value will be positive 1. This is y plus 3, the y value will be negative 3. So you want to change those signs. That's how you're going to locate your center. Again, you're probably familiar with doing that when you do equations of circles. Next, I'm going to find a and b. Again, in my world, I look under the x to get the a, and there's just a 1 there, but you have to remember you're taking the square root of that number, whatever it is, and it happens that the square root of 1 is 1. So a in this case is 1. B, I'm looking under the y piece, which I have a 4, and B is the square root of that number. So the square root of 4 is 2. So there are A and B. And then finally, I want to find my focus point distance. C squared equals big minus small. When I come back up here, my numbers are 1 and 4. So big minus small means 4 minus 1. So C squared equals 3. And C is the square root of 3, which is about 1.7. And since we're graphing, you're kind of guessing at that anyway. Now, this one is going to be different because the center is not at 0, 0. So you need to first locate your center. So we are at 1, negative 3, which is right in here. Everything you count from that center. So I want to count from that center. A is 1. So I'm going to count left and right 1. So I'm going to come over here and here. If I were asked to find those vertices, which have disappeared on me, I would be at 0, negative 1, and at, 0, negative 3, and at 2, negative 3 would be those 2 points that would be on the minor axis. I know it's the minor axis because B is bigger. Since B is 2, I'm going to go up and down 2 from the center, which is going to put me here at 1, negative 1, and then down here at 1, negative 5. My ellipse this time will be very small. And again, you can still tell that the major axis is vertical this time because it is longer. Since that is my major axis, I will be putting my focus points on that. Now, my focus points are about 1.7 away from the center. So somewhere right in here and down about 1.7, somewhere right in here. If you had to come up with the equation, not the equations, the points for your focus points, obviously they're going to have the same y value, the same x value, so that will be 1. And then you will have to add and subtract from the center value to get that. So like you would say 1 and negative 3 plus the square root of 3 is one of them. 1 and negative 3 minus the square root of 3 is the other. Because, again, that square root of 3 is just that distance. And so you would have to come up with those y values from that center distance. Now, as we look at example 3, you'll notice it does not appear to be in standard form. So you have to think about what you're going to do to get it into standard form. And let's come back up and look at standard form for a second. Everything was in fractions and it was equal to 1. That 1 over there is the key to getting the one that we're looking at in number 3 into standard form. If I need this to be 1, then what I'm going to have to do is divide by 36. But I have to divide everything by 36. And again, that will make that right-hand side be a 1. Now, on this side, what happens is these reduce. Sometimes they're nice, like this example. Other times they're a little uglier. But you want to make sure that you write it in such a way that the number is left on the bottom in some form. So here, 9 over 36 will reduce to 1 over 4. So I can write that as x squared over 4. Y squared has the 4 and the 36, which reduces to 1/9. So this will become y squared over 9. Now, can you look at this and tell whether it's going to have a horizontal axis that's the major axis or a vertical axis that's the major axis? So since the number under y is bigger, the major axis will be vertical again. This will be the third example of that vertical look to the ellipse. What is my center? 0, 0, because I have the plane x squared plus plane y squared. What is A? 2, because that is the square root of 4. What is B? 3, because that is the square root of 9. Again, I want to go with c squared equals big minus small, so in this case it would be 9 minus 4. So c squared is 5. C is the square root of 5, which is about 2.2. And I'm going to pause for a minute and let you try to draw this. If you're watching at home, please hit pause. Okay, so if you are drawing this, your center was at 0, 0. Since A was 2, you should have gone left and right 2. Since B was 3, you should go up and down 3 from the center. And then your C was about 2.2, so one stayed up here, the other one kind of disappeared down here, but somewhere in that neighborhood. And again, that's just graphing it. They could ask you not to graph it and give them specific vertices. That's all in the question. They could just ask for the focus points. But knowing how to do all this can answer any of the questions that they present you with. Okay, for our fourth example, I'm going to do one that is definitely not in standard form. And I'm going to show you how to get it into standard form. This is going to require you to complete the square. You may have done that in some previous classes, but we will be doing that here. What you're going to start out by doing is getting the x parts together and the y parts together. So let me highlight. I'm going to get this x piece and this x piece together. I'm going to get this y piece and this y piece together. And I'm going to move that plane 21 to the other side. Okay, so I'm going to rewrite it. 4x squared plus 24x, and then plus y squared minus 2y, and I'm going to subtract the 21 to get it on the other side of the equals. The next thing I'm going to do is look in front of the x squared and in front of the y squared and see what numbers I have. In front of the x squared, I have a 4, which means I'm going to have to do a little bit more work. In front of the y squared, I have an imaginary 1. So that actually makes life a little bit easier. When you have a number like this 4, you will need to factor it out of just that part. So in other words, I'm going to say 4, parentheses, I'm going to take it out. It's going to leave me with x squared. I'm also going to take it out of this 24x, so I'm going to say plus 6x. I'm going to leave space to write something and then close my parenthesis. Over here, because I said we don't have to worry about that with y, I'm just going to write y squared minus 2y, and I'm also going to leave some space before writing the equals negative 21. Okay, now we're going to do what is called completing the square. I'm going to do the y part first because it's fairly easy. You look at the middle piece that didn't have the squared. So here I'm looking at this negative 2y. I'm not going to worry about the negative part. I'm just going to look at the 2. You take half of that number, square it, and add it to both sides. So half of 2 is 1. 1 squared is 1. I'm going to put 1 plus 1 on each side. Over here, it's a little bit more complicated because I'm still going to do that. I'm going to locate that middle piece. I don't worry about the plus or minus. So here I'm looking at a 6, the part that's right in front of the plain X. I'm still going to take half of that number and square it. So half of 6 is 3, 3 squared is 9. I'm going to add that right here. I'm going to add it on this side. But it was multiplied by 4 because there was a 4 outside of this parentheses. And if I distributed, I would get a 4 times 9. So when I add it on the other side, I also have to do a 4 times 9. And you can go ahead and multiply that and write it down as 36, or you can remind yourself where it came from and always put times whatever that front number was if you had a front number. So again, I looked at the y, the number in front of it, don't worry about plus or minus, half of that number, square it, and add it to both sides. Over here, the number in front of x, half of that number, square it, and add it to both sides. If there was a number out front, you multiply by that number. And you could have the situation where you don't have to pull out any numbers because x squared and y squared both have a 1. Not usually in ellipses is that going to happen, but it could happen with circles or stuff like that. You could also have the situation where you had to pull a number out of the y's as well. So if I'd had like 5y over here, I would have had to pull out a 5 and been a little bit more work. Alright, the next step over here, obviously, you're going to add everything. So I'm going to say negative 21 plus 1 plus 9 times 4, and I'm going to get 16. On this side, I'm going to bring down the 4, and I'm going to think about what this factors to. This is actually going to factor to x plus 3, x plus 3, but I'm not going to write it like that down here. I'm going to write it as x plus 3 squared. The y will also work the same way. It's going to factor to y minus 1, because 1 times 1 will be 1, and the negative 1y and negative 1y will be negative 2y. But again, I'm going to write it as y minus 1 squared down here. Now, I generally don't write out this factoring because I can see where it's going every time. It's always going to have the sign that is here in the middle. And it's always going to be half of that number before I squared it. So half of 6 is 3, half of 2 is 1. It's always going to work out that way. But if you need to write out your factoring to come up with that, that is fine. From this point, we're to that situation that we were in number 3. It's not equal to 1. So I'm going to have to come in, and I'm going to divide everything by 16. And obviously over there on the right, 16 divided by 16 is 1. On the left, the 4 and 16 we're going to reduce like we reduced in number 3. So 4 over 16 will reduce to 1/4. So I'm going to write that as x plus 3 squared over 4. There was nothing out front to reduce this 16 with, so I'm going to keep it y minus 1 squared over 16. Okay, so now that I have my equation in standard form, I want to do the same stuff that I have been doing. So my center is where? Negative 3, positive 1. My A is 2, and my B is 4. And again, I have a vertical example. I'm sorry about that. C squared will equal big minus small, so in this case 16 minus 4. So C squared will be 12. C will be the square root of 12, which is about 3.5 roughly. And so now when I go to draw this, I have to remember to count everything from the center. So I'm at -3, +1, which is right here for my center. My A would be 2, so I'm going left and right 2. So here and here. My B is 4, so 1, 2, 3, 4 from the center would put me at -3, 5. And then down 4, 1, 2, 3, 4, I'll be at -3. And there's my ellipse. And then my focus points are roughly 3.5 from the center on the major axis. And the major axis, again, is vertical, but it's not always the case that it's vertical. But I'm going to count 1, 2, 3.5, to the best of my ability anyway. 1, 2, 3.5. And again, those are my focus points. So they could ask you for the actual points of any of the vertices or focus points. They could ask you to sketch the graph. And that concludes this lesson.